To determine if a truss is stable, we can first check that it's determinate, meaning that the number of equilibrium equations is equal to the number of unknowns. And the unknowns are the forces in each member and also the reaction forces. So the number of equilibrium equations is equal to the number of joints multiplied by 2 equilibrium equations per joint, being the sum of forces in the horizontal and vertical direction. So for this truss, we have 4 joints by 2 equilibrium equations, which gives 8 equations. And a number of unknowns are the member forces. So here we have 5 members, plus 3 reactions, being 2 at the pin and 1 at the roller, which equals 8. And therefore the number of equilibrium equations is equal to those of the unknowns, and consequently this truss is stable. Now for this truss over here, we also have the same number of reactions, being 3, and the same number of members, being 5. So the number of unknowns is the same. And we also have 4 joints, so also 8 equilibrium equations. But this truss is not stable, because if we take moments about this point here, using anti-clockwise as positive, we have this external force by the moment arm, being the distance to this joint, must be equal to 0. But because this force and lever arm are both not 0, then this equation is not satisfied. And therefore the reactions are not going to be able to resist a torque that's generated about this point. And this truss is consequently unstable. Now for this truss here, we have 2 unknown reactions. So the number of unknowns is 2 reactions plus 5 member forces, which gives 7 unknowns. And the number of equilibrium equations is the number of joints, being 4, by 2 equilibrium equations per joint, which gives 8. And because the number of equilibrium equations is greater than a number of unknowns, then the system is overdetermined and this truss is unstable. So as you can imagine, because these rollers don't provide resistance in the horizontal direction, then this force is just going to push that truss and it's going to behave like a rigid body. And please subscribe, like and comment to help me reach more students.